Hello, MTED 301. Today we'll be covering factoring and foiling, specifically the how-tos on how we do it. Now, before we start, here's a quick question. How many of you have heard of factoring and, loosely, the term foiling? Well, today we'll be covering it with our standard of performing arithmetic operations on polynomials. The goal is listed on the screen right now, and it is to understand that polynomials form a system analogous to the integers, namely they are closed under the operations of addition, subtraction, and multiplication. Add, subtract, and multiply polynomials. So, when we get into foiling, we have a few steps. The first thing we need to do in order to factor is to understand the steps to it. When we factor, I will be teaching you the FOIL method, otherwise known as our first, outer, inner, and last method. So, with that being said, what does this mean? It means that in any situation where you're given two binomial factors, you multiply them in the order given by FOIL. In the case of this, we have a simple x plus y function, or expression. So, our first, or RF, is the first step. It is to multiply the first terms of both our binomials together. In this case, x plus y is given. Our first terms is x and x. So, when we multiply these together, we are given the following value of x squared. Our next step is outer, or outside. Our next step is to multiply our outside terms together. In this case, we have our x and y. When we multiply these together, we are given the following value of xy. The same goes for our next step, which is inner. Our next step is to multiply our inner terms together. In this case, we have y and x. When we multiply these together, they are also xy. Now, our second to last step inside of our function is to be last. Our second to last step is to multiply our last terms together. In this case, we have y and y. When you multiply these together, you are given y squared. Now, what do you think our last step is? Can we just leave our function as x squared plus xy plus xy plus y squared? No, that is considered improper. Now that we have finished performing FOIL on our binomials, we must now simplify and add any like terms together to create our final polynomial. In the case of this, what are our like terms here? Do any of these share variables, or share any way that we can just add these together? If you guessed xy, then you are correct. When we combine xy and xy, since they have the same variables, we can just combine them to get x squared plus 2xy plus y squared. And this is our finished polynomial. Now that we've covered the specifics on how exactly we perform this operation, let's go ahead and go over a few example problems. For our first example problem, I will be showing you the perfect square binomial pattern. In this case, if you were ever given two values and when they're in a binomial are just put as x plus y and x minus y, it is a very simple pattern, but I'll show you the specifics behind it first. So, when we perform the FOIL method, we come out with this following expression of x squared plus xy minus xy minus y squared. Now, when you look at this, you can tell that xy and negative xy cancel each other out. They are no longer inside the term because xy minus xy is just 0. So, when we perform our simplification, we're just left with x squared minus y squared. Now, this is a pattern that is seen all throughout binomials. Whenever you see two binomials and they are the inverse, as in x plus y, x minus y version of each other, then you know for a fact that you will be left with x squared minus y squared. Let's see it. So, this solution works for all types of binomials. When you see the following, you'll see that x plus 7 and x minus 7 comes out to x squared minus 49. X plus 3, x minus 3 is equal to x squared minus 9. And x plus 6, x minus 6 is equal to x squared minus 36. In other words, all these binomials, when they are given the inverse of each other, multiply into this specific pattern. Now, when it comes to example problem 2, when it comes to the actual FOIL process, you must make sure that you follow the steps very carefully. Here's an example of a basic FOIL question. Go ahead and give this a shot, and then we'll go over it shortly. So let's go ahead and follow along. Remember what we must do. FOIL are first, outer, inner, and last. For our f, we'll notice that our front is x and x, so we multiply it to get x squared. When we multiply our outer terms, we get x times 12, which is 12x. Our inner terms is negative 5x, not negative 5, and x. The negative is important. Be sure to keep that in mind. Negative 5 times x is just negative 5x. And finally, our last terms, which is negative 5 and 12, which multiply together to get negative 60. So, when we simplify and add all of the variables together, you'll notice that we have x squared plus 12x minus 5x minus 60, which sums up to x squared plus 7x minus 60 after combining all of our like terms. Did you get this answer? That's good. So for our final example problem, we will now show how do we deal with more multiple variables and higher levels of powers in our binomials. In this case, it looks a bit challenging. We have x squared plus 12y and x squared minus 6y. Go ahead and give it a shot, and then we'll go ahead and go over it. So, while the equation does look more complex than our other binomials, the process does not change. We still follow our simple step of FOIL. When we look at our first terms, x squared and x squared, we multiply them together. Our outer terms are x squared and negative 6y. Our inner terms are 12y and x squared, and our L, or last, is 12y and negative 6y. The only thing to keep in mind when performing this particular operation is that although the steps have not changed, it is a bit more complex in that you have to be a bit more careful with the way you organize your variables. So let's go ahead and take a look. When we simplify and add all of our variables together, we get x to the fourth power minus 6x squared y plus 12x squared y minus 72y squared. When we simplify this, you'll notice that our like terms are a bit more complicated. When we take a look, we have to be a bit more careful with the way that our like terms look, because when looking at it, our like terms here are negative 6x squared y and positive 12x squared y. When we combine those, we'll get positive 6x squared y. With that being said, thank you for listening, thank you for following along, and I'll see you in the next one. Bye-bye now.